All right, so if you had just been asked to solve this equation with no other specifications given as to how to solve it, this would be a correct answer. But because the question specifically stated that the solution was to be expressed in terms of natural logarithms, that's why this part of the answer was marked incorrect. So let's just take a look at how you were actually asked to solve this. So let's take a look at that. So to use natural logs would mean that I'm applying the natural log to both the left and the right side of the equation. I'm now going to use the power rule, which says this power on 5 can actually become the coefficient of the logarithm. And now I'm going to use the distributive property, and I'm going to multiply x times the natural log of 5 and add to that 1 times the natural log of 5, which is just the natural log of 5. And I want to isolate x. So to do that, the first thing I'm going to do at this point is to subtract the natural log of 5 from both the left and right side of the equation. So on the left, I'm simply left with x log 5, and on the right, I have the natural log of 421 minus the natural log of 5. And in order to isolate x at this stage, I simply need to divide both sides by the natural log of 5. Both sides of the equation. And here, these natural log of 5s divide out, and I'm simply left with x, which is exactly what I wanted to be left with. And on the right, I have the natural log of 421 minus the natural log of 5 all over the natural log of 5. And that would be a acceptable form for the exact final answer in terms of natural logs. Or I could use the quotient rule in the numerator here and write this as the natural log of 421 over 5 divided by the natural log of 5. So you could do that. It's not necessary. Either one of these would be correct. So that's what the first part of the solution to this problem should have looked like. You don't have to have this form of the answer. You could use any base log to get the answer, but you were instructed to use the base E log, the natural log. So that's why this part was marked incorrect. Now let's take a look at why this is incorrect. And let's look carefully at the instructions. Use properties of logarithms to condense the logarithmic expression. Write the expression as a single logarithm whose coefficient is 1. Where possible, evaluate logarithmic expressions. All right, so our goal then is to condense this log. So let's take a look at doing that. All right, so the first thing that I would do in a problem like this is I would probably distribute this 1/8. So 1/8 times 5 is 5/8. Times the natural log of x plus 9 minus 1/8 times the natural log of x minus 1/8 times the natural log of x squared minus 49. Then I would apply the power rule of logarithms. So these coefficients now are going to become powers of the inputs to each logarithm. So the input to the first log is x plus 9. So the 5/8 becomes the power applied to x plus 9. This 1/8 becomes the power applied to x. And notice how I left the minus sign here. I only worked with the numerical portion of that coefficient as my power. All right, so there I've applied the power rule. Now I'm going to do something else, and that is I am going to make use of the distributive property, but I'm kind of working backwards from the way we normally work with it. So I'm going to factor out, in a sense, a -1 here, and I get a sign change in here when I do that. All right, now I'm going to apply the product rule to this sum of logs inside this parenthesis. So when you're adding two logs of the same base, you can write one log and multiply those inputs. So I'm multiplying the inputs to these two logs that were being added. And I am using essentially the product rule. Now I have a subtraction of two logs, and that requires an application of the quotient rule in order to follow the instructions given for the problem. And notice how you can see right here where this differs from the answer that you had. You had a subtraction between these two terms rather than a product. So that's why this was incorrect. And then, so we've got a single log whose coefficient is 1. Let's look back at the instructions. Notice when you look at the format that you're being asked to enter in, you're told to type in exact answer, use radicals as needed. Type your answer in factored form. Do not rationalize the denominator. So in other words, because I have a fractional power, I can use a radical. So for me to continue here, I notice every power has a denominator of 8. So instead of writing this as a power, I'm going to write an 8th root. So this is the natural log of the 8th root of x plus 9 to the 5th over x times x squared minus 49. All right, and let's look back at those instructions again, which tell me to type your answer in factored form. So, given that those are my instructions, even though this is numerically correct at this point, it would be marked incorrect because it's not in factored form. So I need to factor x squared minus 49 into x minus 7 times x plus 7. And I also was told to use radicals as needed. So I wouldn't want to leave those fractional powers. I would want to write them as a radical. Use a radical instead. So this would be the final answer that was desired. Okay, so that would be the process to follow on this problem.